Welcome back to Every Problem. This is Stewart Calculus 8th edition, section 1.1 and problem 28. This problem is going to involve quite a bit of algebra, and you'll see why it does have to do with this x cubed right here in the picture. But let's get started. So, number 28, I'll just rewrite the problem. F of x equals x cubed. And what they want is they want us to use the difference quotient for f of a plus h minus f of a all over h. Okay? And as mentioned on problem 27 and a problem before that, when we have this f of a of h, it does not mean f times a of h, right? We're not necessarily multiplying anything in that manner. What we're doing is we're taking a function f, which is a rule, right? And in this case, our rule f with our variable x is equal to that variable cubed. So that's what that means. And so what they want us to do is anything in parentheses here, we're going to plug into our function. So what we have is we have f of a plus h minus f of a all over h. So we have, hold on, I'll write this in black. We have a plus h cubed minus a cubed all over h. And this is going to get, yeah, we'll have to do some algebra for this. If you know Pascal's triangle, that could make this go quicker, but we'll save that for now. That could be for a different video. So we'll just multiply it all out by hand. We have a plus h, and remember when this is cubed, we absolutely cannot just say, oh, well, that must be a cubed plus h cubed. That's not what we're supposed to do. Okay. What we are supposed to do when we have a plus h quantity cubed is we're supposed to write it 3 times. A plus h times a plus h times a plus h. And let's just go ahead and start with multiplying it out. So we have a squared plus ah plus ah plus h squared, which simplifies to a squared plus 2ah plus h squared. But we still have one more a plus h to multiply. So now we'll do this. We get a cubed plus a squared h plus 2a squared h. I'm just going a little slowly. I don't want to accidentally make a mistake with this. Plus 2a squared h plus 2ah squared plus a squared h. Oh, sorry, ah squared plus h cubed. And so we see that we have some like terms. We have the a squared h's, and we also have the ah squareds. So now that does simplify down a little bit into a cubed plus 3a squared h plus 3ah squared plus h cubed. Now, remember, that was only the left side, right? That was only this part up here. Oh, sorry, not that big of a circle. That was only this part here. We still have this minus a cubed that we need to bring back down. So minus a cubed. And this is all over h. Okay, let's just rewrite this for cleanliness, right? A cubed plus 3a squared h plus 3ah squared plus h cubed minus a cubed all over h. Now what we do notice is we have an a cubed and we have a minus a cubed, so those do cancel out, which is nice. Another thing that we notice is we do have h's. So we can factor out an h as well. So let's go ahead and do that. We have h times 3a squared plus 3ah plus h squared all over h. And so luckily, right, the h's cancel. And we are left with 3a squared plus 3ah plus h squared. And that is our final answer.